Great to see you here again. This will be a short presentation. In this presentation, I will talk about sampling and how we create control charts. When we spoke about hypothesis testing before, I showed you different types of hypothesis testing. Now, I already explained that the principle of control charts is based on the principle of sampling. Now, what are we going to do? We're going to take a sample. For example, we take 5 bottles of some liquid, some beer, some wine, water, whatever we have in the factory, and we measure the content of each bottle and we calculate the average. Basically, what we do here is we calculate let's say, the sample average. And that sample average we have to compare with a control chart or with the two-tail testing, because what we want to do, we have a null hypothesis that the content of the bottles is, for example, equal to 1.5 liters, and the alternative hypothesis says it's not equal to 1.5 liters. So we set the borders here at 99.7%. So between the left hand and the right hand zone, there we have 6 sigma, 3 sigma to the left and 3 sigma to the right. And when we have one sample, we will see, is that sample between those borders? And if the sample is between the two borders, we can say, okay, this is great. So basically, the two-tail testing will tell us if the sample that we took complies with the null hypothesis or not. And once we find out that that sample average is between the borders, we can say that the sample is accepted. So we consider that the process is producing items which are in fact according to the specifications. Now, what we do in sampling in control charts, we do that sampling at intervals. We take specific intervals during the day and we take a sample. We do the same thing and we put that number or that average in the graph, in a graph showing on the top the upper control limit, let's say the right hand side of the graph, and on the bottom, the left-hand side of the graph. So basically, we build a chart where we see every sample average like this. So basically, we see a chart like this, and we see basically around the mean, around the average, we have the normal distribution. And on the top, we have the upper control limit. Below, we have the lower control limit. And we see when it's red, when the value, the average is above the upper control limit, the sample is out of specification, so we will reject the null hypothesis. We will accept the alternative hypothesis saying that the sample is not compliant. The same we do when we are below the lower control limit. But let's have a look when we have some different measurements here. We have 3 measurements here. We have the 2 blue ones. They're clearly between the borders. So basically we can say that these are samples and the position, the difference in position is in fact due to common cause or natural variation. These samples are accepted to be correct. Unfortunately, the sample below, we will take the conclusion that we have to reject the null hypothesis, accept the alternative hypothesis saying that the sample is out of specifications. We cannot accept it, and basically the sample has to be rejected. We have a problem here. So basically here, this is a clear position. We can see that this sample is out of specifications. Now here we do it for just 3. When we do a control chart, we have a lot more points that we have available, and we will calculate the mean, the upper control limit, the lower control limit, based on special formulas that I will show you later, formulas that have been developed by the people who are specialized in statistics to create these charts, because we have to find out the mean, we have to calculate the upper control limit, we have to calculate a lower control limit. So this, for example, we look at the averages, the filling of the bottles, we see where they are. Now, when we have larger samplings done, we will see that we can see certain trends and patterns. And what we can say is that a good pattern when we have common cause or natural variation is that the numbers, that the sample averages are evenly spread around the mean. So this is basically the idea how we create a control chart. The idea behind it is the hypothesis testing, which is in fact done on a large number of successive samples. It was a short presentation, but now you understand how we create a control chart, and in the next videos we will look at more elements that are important to create and to evaluate these control charts. And like I said, control charts are very important. It will give us an insight into the quality of the process. And when we find things that are strange, which indicate that something is wrong, we will use that control chart to say, hey, we have to stop the process, we have to review the process, we may have to repair the machinery that's working on the items that we are checking, and so on. But that's for later. So thank you very much, and I'm looking forward to seeing you in the next video. Thank you, and bye-bye.